Hi, my name is Ankit and welcome to Prabotech. In this video, we will learn about factual and counterfactual explainers. So we will see what are factual explainers and then what are counterfactual explainers, and then we will discuss some examples to understand them even more clearly. So factual explainers, basically, as the name says, that they are based on fact. I mean, based on what actually happened, right? So basically, they tell which parts of the input actually influence the model's current prediction. Now, you may be wondering that this is what explainers used to do normally, right? They highlight which parts of the input graph actually influence the model's predictions, what's new. So the new thing is that they do not change anything in the graph, right? So you will soon understand what point I am making here when I'll go to counterfactual explainers. So basically, what you can keep to yourself right now is that factual explainers basically highlights important information from the graph that influences model's prediction, but they do not change anything in the graph, right? Now, these are useful when you want to understand the model's reasoning, when you want to debug unexpected predictions, or if you want to visualize important subgraphs. That's a basic thing that explainers are supposed to do. So counterfactual explainers are basically interested in what could have happened but did not. So they are basically interested in answering what is the smallest possible change to the graph that would flip the model's predictions, right? So this is something different, which you have not heard so far coming out of explainers, right? So counterfactual explainers are basically useful when you want to understand models' sensitivity. I mean, if you do some changes in the graph and the model's predictions are flipped, so you take a note of the sensitivity of the model, right? If you're interested in that, counterfactual explainers are your tool, right? If you are interested in exploring what if scenario, for example, in molecular property prediction task, if you are if your model is predicting some property, and if you are interested in knowing that what should I change in the molecule so that I get a different property value. So in this kind of scenario also, counterfactual explainers are your choice and not factual explainers. And thirdly, they give actionable feedback. Now, factual explainers only give you feedback. Uh, for example, they say that this particular subgraph is important in your graph, or this node feature is important in your graph, but they cannot propose you any action. But on the other hand, counterfactual explainers basically give you an action to do, right? To get the desired prediction that you want from the model, right? So the core difference between the two is that factual explanations basically look backward, whereas counterfactual explanations look forward. And the choice of explainer, of course, depends on you and your point of interest. What do you want to do with your model, right? What do you want to know, right? So let's take an example of drug toxicity prediction. And let's say a model predicts this molecule is toxic, right? This molecule on your screen. And if your point of interest is why is this molecule toxic, then your choice should be factual explainers because they look at the molecule as it is and they will ask, which parts of this structure cause the model to predict toxic, right? It does not change the molecule at all. So the explainer in this case, a factual explainer, might highlight a specific structure, a specific substructure or subgraph like this. For example, a benzene ring is causing the molecule to be predicted as toxic, or it may highlight some node feature like electronegativity or charge responsible for the toxicity of this molecule. So they give you feedback on what is the reason behind your prediction, right? In this case, the molecule being toxic. If your point of interest is how could this molecule become non-toxic, which is a legitimate point of interest. So in this case, your choice should be counterfactual explainer, right? So it modifies the structure slightly, like you can see in this figure, and tries to flip the prediction, keeping the change as small as possible, right? So the explainer might answer in this case that you should remove this bond, or you should replace this functional group, or maybe you add an extra atom here or there. So things like that, right? So this is the difference between factual explainers and counterfactual explainers. So this is it in this video. We discussed factual explainers and counterfactual explainers, and also the examples where the same graph machine learning problem can be handled well with factual explainer in one case and with counterfactual explainer in the other case. It only depends upon what our point of interest is. So I hope you now have a good understanding of factual explainers and counterfactual explainers, and you can make good decisions in your own graph machine learning problems as to with which explainer you want to go. If you have any questions, feel free to leave comments. Thank you so much for watching. Wish you all the best.